Hi, this is Cliff Nelson from Redwood Tutoring, and I'd like to talk with you about factoring expressions of the form x squared plus bx plus c. Well, before I actually get to these expressions, I want to do some preliminary work. Let's say that I'm looking for two different numbers, and these numbers must multiply to 20, and they have to add to 9. They multiply to 20 and they add to 9. Well, those two numbers are 4 and 5. Now, it doesn't matter the order. You could write 5 and 4 or 4 and 5. Either way is fine. Now, see if you could guess the numbers before I actually write them up on the board. Looking for two numbers that multiply to 63 and add to 16. Multiply to 63 and add to 16. Well, it looks like 7 and 9 will do the trick, because 7 times 9 is 63, and 7 plus 9 is 16. Let's do a couple more. Say that I have two numbers that multiply to negative 18 and add to 3. Now, something different happens when you have the top number being negative. The only way the product could be negative is if one of the two numbers is negative and the other is positive. That's the only way that they can multiply to a negative number. In this case, negative 3 and positive 6 will do the trick. Negative 3 times 6 is negative 18, and negative 3 plus 6 is positive 3. Let me go ahead and do a few more of these, and then I'll show you how to apply it to factoring expressions of this form. Let's say that I am looking for two numbers that multiply to negative 35 and add to negative 2. Well, here again I have the product being negative. That guarantees that they have opposite signs. One of them is negative and one of them is positive. Looks to me like negative 7 and positive 5 will do the trick. Negative 7 times 5 is negative 35. Negative 7 plus 5 is negative 2. Let's do two more. Something a little bit different happens when you have a positive number on top, say 40, and a negative number below, say negative 13. Now, whenever the product is positive, that means that the two numbers have to have the same sign. They're either both positive or both negative. And since they add to a negative number, that means that they have to both be negative. So it looks to me like negative 5 and negative 8 will do the trick, because negative 5 times negative 8 is positive 40. Negative 5 plus negative 8 is negative 13. Last one, and then we'll get to some real problems. Let's say that I have 77 on the top and negative 18 on the bottom. 77 on the top, negative 18 on the bottom. Here again, they have to have the same sign. Here again, they both have to be negative. That's the only way they sum to a negative number. And it looks like negative 7 and negative 11 will do the trick. Negative 7 times negative 11 is positive 77. Negative 7 plus negative 11 is negative 18. All right, so let's figure out how to apply this to factoring the trinomials that we were out to factor. Suppose that I want to factor the following trinomial. Let's say that it was x squared plus 7x plus 12. X squared plus 7x plus 12. Well, what I do is I take this 12, the constant term, and I put it at the top. And then the coefficient to the x, in this case 7, goes below. And then I do the same trick, and I say I'm looking for two numbers that multiply to 12 and add to 7. Well, those two numbers are 3 and 4. And then here's how I split this into two binomials. This is going to factor as x plus 3 times x plus 4. Now, because these could be in either order, that means these factors could also be in either order. I could have written x plus 4 times x plus 3. Now, this is going to be my final answer, but it'll be helpful for us to just FOIL, just to double check to make sure that this works and to see why it works. X times x is x squared. This is going to give me plus 4x. These give me plus 3x. And then last, this is plus 12. So if I combine like terms here, this is going to give me x squared plus 7x plus 12. And sure enough, this is exactly what I started off with. Now, I hope that you could see why we were looking for two numbers that multiply to 12, because the last terms have to multiply to give me my 12. And why I was looking for two numbers that add to 7, because I need to have these two combine to 7x. Let's see if we could do another one. I'd like to try to factor the following trinomial. Let's say that I had 5x plus x squared minus 14. Well, the first thing you might think is this doesn't quite look right. It's not in the form that we're used to. We're more used to writing it in descending powers of x. So I recommend that your first step is just to rearrange the terms x squared plus 5x minus 14, write them in descending powers of x. And then the constant term is what's going to go on the top, negative 14. And then the coefficient of the x is what's going below, the 5. And I'm looking for two numbers that multiply to negative 14. That means they have to have opposite signs and add to 5. It looks like it's going to be negative 2 and a positive 7 will do the trick. So this is going to factor into x minus 2 times x plus 7. And if you don't actually write it down, at least double check to make sure that this is right by foiling in your head. X times x is x squared. This is going to give me 7x minus 2x. That gives me my 5x. And this is going to give me negative 14. That looks great. This looks like our factorization. Now, I want to do one final problem, but before I do, I want to write up a caution, because this technique, even though it's very common, it doesn't always work. You can notice how here my coefficient of the x squared was a 1. But if I had any other coefficient, say if this was a 2, a 5, a 17, anything besides 1, then this technique doesn't work. We'll have to do something different. So here's my caution. My caution goes like this. This technique doesn't work for trinomials of the form ax squared plus bx plus c, where a happens to be anything besides 1. If you have something of this form, you have to do another technique, which I plan to talk about in a different video. Let's do one final problem. Clear off some board space. And here's our last problem. It is 5x squared minus 20x plus 15. Well, the first thing you will recognize is the coefficient before the x squared is not equal to 1. So the technique that we've been using, it doesn't work without some modification. Now, as it turns out, I get a little bit of a lucky break for this problem, because all of these terms have a 5 in common. I could factor out a 5, and then I'm going to be left with x squared minus 4x plus 3. And then here I do have a 1 as my coefficient. So for this trinomial within the parentheses, I could use that technique. I'm looking for two numbers that multiply to 3 and that add to negative 4. Well, I know that those two numbers have to have opposite signs, and it looks to me like negative 3 and negative 1 will do the trick. So this breaks down, don't forget to keep writing the 5, this breaks down into x minus 3 times x minus 1, foiling that matches up with what I want, and so this will be my final answer. Well, thank you for joining me, and have a great day.